Gaussian mixture models or GMM. Gaussian mixture models is a probabilistic clustering algorithm that assumes data points are generated from a mixture of several Gaussian distributions with unknown parameters. Now, GMM assigns a probability to each data point for belonging to each cluster, making it a soft clustering technique. It is particularly useful when clusters have different shapes or densities. Let's go ahead and implement this Gaussian mixture model GMM clustering in Python. So I have already created a file. I'm going to go ahead and first import the necessary libraries. Next, I'm going to from sklearn mixture import Gaussian mixture, which import the Gaussian mixture class from scikit-learn's mixture module. Now, Gaussian mixture is a clustering model that assumes that data is generated from mixture of multiple Gaussian distributions. It is used for identifying clusters in data when clusters may have elliptical shapes. So next, let's import numpy as np, which imports numpy library which provides support for numerical operations and array manipulation in array. Next, let's get our sample data that we've used before, which are points in 2D space, x equal to np array, and I've given all these points, which defines the feature data x as a numpy array, where each sublist represents a data point in 2D space with two values, x and y coordinates. For example, 1, 2 and 8, 7 are 2 points in 2D space. The shape of x is 6, 2, meaning there are 6 data points with 2 features each. Next, let's go ahead and initialize and fit the model. So I'm initializing the model by saying Gaussian mixture n components equal to 2, random state equal to 42. This initializes a Gaussian mixture model with the following parameters of n components equal to 2, which specifies the number of Gaussian distributions or clusters to fit to the data. This parameter represents the assumed number of clusters in the data. Random state equal to 42. It sets a random seed for reproducibility, ensuring the initialization of the model is the same each time the code is run. Let's go ahead and fit it. gmm.fit pass x. This fits the Gaussian mixture model to the data x. During this process, the model estimates the parameters of the Gaussian distribution, mean and covariance that best describe each cluster in the data. Let's get the cluster labels and probabilities. Labels equal to gmm.predict and probabilities equal to gmm.predictproba. These are the functions. The first one predicts the cluster labels for each data point in X. The predict method assigns each data point to the cluster with the highest probability. The output is an array of integer labels representing the cluster to which each point belongs. The second line number 14, calculates the probability that each data point belongs to each cluster. The predict proba method outputs an array where each row represents a data point and each column represents a cluster. The values indicate the probability that each point belongs to each cluster, providing a soft clustering assignment that is allowing each point to have a probability distribution over clusters. Now let's go ahead and print the cluster labels and print the cluster probabilities out. So let's go ahead and run this on our command prompt or terminal. I'm going to say Python Gaussian mixture models, run it. And here you go. Based on the numbers that we have provided, it's going to create cluster labels for each one of them. This one is very separate, so that's why, since we said 2, it created 2 different clusters, 0 and 1. And here are the cluster probabilities, which is very high, 1 and 0. So that means it's good probability that they are in 2 different clusters. Now this code here demonstrates how to use a Gaussian mixture model for clustering points in 2D space. Unlike k-means, which we did earlier, which assigns hard cluster labels, GMM provides soft cluster assignments by assigning each point a probability distribution over clusters, making it particularly useful for overlapping or elliptical clusters. So if you have any questions or any issues while implementing this, let me know and I'll get back to you.